Hello students, welcome back to the 8th video of this playlist. So in this video, we will be solving question number 8 from the most recent past paper of Pure Mathematics 3, that is October 2024 P3 paper. So let's see what's the question number 8 from this paper is about. So question number 8, here you go. Okay, so you can see question number 8 on the screen. So basically the concepts behind question number 8 is from very last chapter of your Pure Mathematics 3 textbook, which is numerical methods. To be more specific, we need to deal with locating locating roots here. We need to deal with fixed point iteration in this question. So in order to be able to solve this question, definitely you should have solved sufficient questions from chapter number 8 of your Pure Mathematics 3 textbook. So let's get started with question number 8. So right at the beginning, you can see a figure number 4. The heart rate of a horse is being monitored. Okay, the heart rate measured in beats per minute, BPM. Okay, beats per minute is modeled by the equation H equals 32 plus 40 E inverse 0.2t minus 20 E inverse 0.90. Okay, where t minutes is the time after monitoring began. Fine. So figure 4 is a sketch of H against t. Okay, so use the equation of the model to answer parts A to E. Okay, so this is the scenario of the question number 8. So the first part, that is A, it's asking to state the initial heart rate of the horse. Okay, initial heart rate. So initially, what would be the value for t? The value for t would be initially what? T equals to 0, isn't it? Okay, so initially the value for t is what? 0. So if t equals to 0, then what would be the value for h? Okay, so the value for h would be 32 plus 40 e inverse 0. E to the power 0 is what? 1. So 32 plus 40, 32 plus 40, and then what's there? Minus 20. Yeah, 20. E to the power 0 is what? 1. So minus 20. Minus 20. So what would be the value? 32 plus 40, which is 52, minus 20, there is 32 what? Beats per minute, isn't it? The unit is given as beats per minute, or BPM in short. Okay, so what we can write, the initial heart rate. So initial what? Heart rate is what? 32 BPM. That's what part A has asked for. Okay, next is part B. So in part B, they are saying in the long term, the heart rate of the horse approaches L BPM. Okay, in the long term, that means long term represents what? When t tends to infinity, basically. Okay, state the value of L. Okay, as t tends to infinity, look, as t tends to infinity, E inverse 0.2t and E inverse 0.90 will get closer and closer to what? 0. Okay, so if E inverse 0.2t and E inverse 0.90 are 0, then these two terms are 0. That means the long term heart rate would be what? 32. Right? The value for L is what? So the value for L is what? 32. L equals to 32. That's what exactly part B of question number 8 has asked for. Fine. Okay, next is part C. So part C here is saying the heart rate of the horse reaches its maximum value after T minutes, capital T minutes. Okay, maximum value. Okay, maximum value. Okay, fine. Part C is asking to find the value of T, giving you an answer to 3 decimal places. Okay, so we need to find out the time, okay, when the heart rate of the horse is reaching its maximum value. So the equation that represents the heart rate of the horse at different times, it's given there. So maximum, we need to find out the maximum value. So if you see the sketch, this is basically the maximum turning point. So there, what we need to consider at that point, what dH/dt, the rate of what, the rate of heart, the heart rate will be what, maximum. dH/dt equals to what, 0. Okay, so right at first we need to what, differentiate. Let me write the equation at first. That is h equals to 32 plus 40 e inverse 0.2 t, then minus 20 e to the power negative 0.90. Okay, 90. Okay, fine. So now let's differentiate. dH/dt would be what, 40 times negative 0.2, that is negative 8. So negative 8 e inverse 0.2t minus minus, it makes it plus. So 20 times what, 0.9, it's basically what, 18, plus 18 e to the power negative 0.90. Okay, so at t equals to capital T, what rate will be the maximum, right? Okay, dH/dt is basically the rate of change of what, rate of change of the heart rate of the horse. Okay, so dH/dt, that would be 0. Okay, so what we can write, 18 e inverse 0.9 capital T minus 8 e inverse 0.2 capital T, that would be equal to what, 0. Okay, so what we can do, we can divide both sides by e inverse 0.2t. So 18 e inverse 0.9 capital T over e inverse 0.2t. Okay, why am I doing this? So that this one gets eliminated. Okay, so got eliminated. Okay, so what you will get, 18 here, e inverse 0.90, so e to the power minus 0.90 minus 0.2t, that is e to the power negative 0.90, that would be plus what, 0.2t. This is equals to what, 8. Fine. So e inverse 0.7 capital T, this is equals what, 8 over 18, which is 4 over 9. Okay, so take ln on both sides, you'll get negative 0.7 capital T equals to what, ln 4 over 9 or 7, 4 over 9, that's correct, 4 over 9. Okay, so we got the value for capital T. Just what, ln, use your calculator, ln 4 over 7, ln 4 over 7, sorry, 4 over 9, divide negative 0.7. So the value for capital T, this is 1.158471737. Okay, so how many decimal places they wanted? 3 decimal places. So up to 3 decimal places they wanted only the value of T, so the unit doesn't matter. So T can be written as what, 1.158 up to 3 decimal what, places, and that's what exactly the value of T wanted by part C of question number 8. That's it. Okay, next is part D. So in part D, they're saying the heart rate of the horse is 37 bpm after m minutes. Okay, fine. So this is the value for h. H equals to what? 37. Okay. Show that m is a solution of the equation t equals to 5 ln 8 over 1 plus 4 e inverse 0.90. Okay. So h becomes 37 at that time. We need to show that. Okay. So just equate what? H equals to 37, isn't it? Okay. So let's go to the next page. So for part D, isn't it? For part D, h equals to what? 37. So if h equals to 37, that means what? 32 plus 40 e inverse 0.2t minus what? 20 e to the power negative 0.90. This is equals to what? 37. Okay. So take 32 to the right side, so you'll get 40 e inverse 0.2t minus 20 e inverse 0.90 equals to what? 37 minus 32, this is 5. Okay. Now you might get confused here, like what we need to do next. Okay. So what you need to do next, it depends on the question, like what they want actually. So on the right hand side, you can see it is what? 5 ln 8 over 1 plus 4 e to the power what? Negative 0.90. So e to the power negative 0.90 is on the right side, right? So what we need to do accordingly, we will take e to the power, the term with e to the power negative 0.90 to the right side. Okay. Okay. So if we do so, what we will see, e to the power negative 0.90 should be taken to the right side, so you will get 40 e to the power negative 0.2t equals to what? 5 plus 20 e to the power negative 0.90. Okay. So then we can make e inverse 0.2t the subject. Okay. So we'll get 5 over 40 is what? 1 over 8 plus half e to the power negative 0.90. Okay. Now what we can do next, we can take ln, right, to eliminate the to eliminate the exponential. So take ln. If you take ln, you will get negative 0.2t here, and on the right hand side you will get ln. Take LCM. If you take LCM, you will get 8, and you will get 1 plus 4 e inverse 0.9t. Okay, we got something relevant to the right hand side that is wanted by the question, isn't it? So now make t the subject as part of the question. So you'll get 1 over negative 0.2, which is 5, negative 5. Okay, negative 5 ln 1 plus 4 e inverse 0.90 over what? 8. Fine. Now we have negative in the coefficient, so take it to the power using the power rule of logarithms. So you will get 5 what? 5 ln. If the power is negative, we can make it inversed, isn't it? So you will get 8 over what? 1 plus 4 e inverse 0.9t. That's what exactly the question has asked to show, isn't it? Exactly, that's what the question has asked to show. And that's the end of part D. Okay, next is part E, the last part of question number 8. So using the iteration formula. Okay, this iteration formula that we have just derived in the part D, t of n plus 1 equals to 5 ln 8 over 1 plus 4 e inverse 0.9 t of n, with t1 the starting value should be 10. So part E is asking to find, part E1 it's asking to find to 4 decimal places the value of t2. Okay, we need to find out the second term of this iteration method. Okay, so t1 is known, right? So we need what? T2. So T2 it's given by what equation? Part E1. We need T2. So T2 would be 5 ln 5, okay, 5 ln 8 over 1 plus 4 e inverse 0.9 times what? T of n. T of n is basically the T1, because here it is T1 plus 1 makes it 2, right? So we need the previous term, which is T1, which is what? 10. Okay, now just calculate the value using your calculator. So if you take this equation ln 8 over what? 1 plus 4 e inverse 0.9 times 10, this is basically negative what? 9. Negative 0.9 times 10, this is what? Negative 9. So that would give you 2.0789 something times 5. Multiply it by 5 to get the value, which is 10.39474012. So they wanted the value up to 4 decimal places. So this is 10.3947. This is 4 decimal places. That's it. That's the answer for part E1. Fine. Okay. Next is part E2. So in part E2, they are asking to find to 4 decimal places the value of what? M. Okay. So we need to find out the value for M. So M is what? M is the solution to this iteration equation, isn't it? So let's solve this iteration what? Equation that we have derived. Okay. So this is what? Iteration. Iteration means we need to do the process what? Repeatedly, isn't it? So for in that case, how do we approach it? At first, the starting value is what? 10. T1 is what? 10. So at first take T1 10 in your calculator and then press equal and then press AC to keep it saved. And then take the equation, the iteration equation in your calculator. So 5 ln 8 over 1 plus 4 e inverse 0.9. In place of what? T of n, you will put what? Answer. Okay, so that we can use it for repeated what? Method. Okay, so now press equal. You will get the value for T2 now. T2 is 10.3947. That's what we got exactly in part E1. Now keep doing the iteration formula. The method repeatedly. Keep pressing. So you will keep it pressing until you see that up to 4 decimal places the values are not changing. Okay, so this is basically after pressing for a couple of times, I could see that the value comes as what? T equals to what? 10.39547.898. Okay, it's not changing other than that. Okay, so the value of M up to 4 decimal places, that would be 10.3955. This is up to 4 decimal places, and that's what exactly the part E2 has asked for. And that's the end of question number 8 from October 2024 paper. Fine.